Start your ABC analyses simple. You'll have plenty of time to make them more complex later. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today we're talking, well, mainly about the plant maintenance side of ABC analysis. We use ABC analyses in different areas of continuous improvement, TPM, but one of the key examples where this system is used is in plant maintenance. Whether you use it as a TPM pillar or a general continuous improvement concept, when we are looking at what machines require very active plant maintenance, where do we need to keep more spare parts on stock, which machines require the best sort of contracts to service them, or very good in-house teams can always get them back up and running, or increase the reliability so much that that isn't even really needed. We understand that you don't want to do this with all of your machines because that is very expensive. So we generally propose that the maintenance team, plant maintenance pillar, make an ABC analysis with A, machines being critical, they need to run, and when they go down we need to very quickly get them back up and running. B, machines that are quite important to the whole operation, and then C, machines that, well, honestly, it's not good that they break down, but nothing really bad happens to the operation. So it is a nuisance, but we've got backup systems, or we can plan them out, things like that. Well, so if they are back up in a couple of days or so, it's probably going to be okay. Now, this type of analysis, and I've seen different versions of it, but a very commonly used version is where you look at the machines and then parts of that machine, and I'm not talking screw number 5, but I'm more talking about the filling unit, the belts connecting it, the active cooling part, the shrink wrap system that's on a line, right? So we look at functional parts of that whole machine, and then we have a couple of criteria. And this can go up to quite a number I've seen from time to time. Things like how important is it for production? How expensive is it if the machine stops? How safe is it or unsafe when you have a breakdown or a special situation? How all kinds of things. How often have we seen breakdowns in the past? How long did they generally last? So a whole bunch of criteria. And we then generate a total score from that. This system is really nice, right? So if we see that specific parts here important, so we see that one part on a machine gets a total score of 50, some part on another machine gets a total score of 20. We can really see that we need to get that part in a good, reliable shape. We need to have those spare parts to fix that area of the machine rapidly. But even though this works quite well, it is very complex, and it is too much when you are just starting out your TPM or general CI journey. So when your plant maintenance system is not really existent, so to say, if this is the first time that you are really looking at it in such a structured way, keep it simple, simpler than this. You want to, and that is what is standard in TPM as well, you want to discuss it with the other pillars. Or in a more generalized sense, you want to discuss with production, finance and planning, what are critical machines? So which entire lines have to be up and running? And this is basically determined by also looking at things like your machine saturation, your asset utilization. So if you have a line that has to be up more than 90-95% of the time, because when it goes down, we're immediately ticking off customers because we're just not producing enough product to deliver to the market, and we don't have a different line to back it up, or that other line is also at 95%, so right? These are lines that need to run and that need also planned downtime, if downtime at all, because when you plan it, you can already prep your customers and your supply chain. They also, if they go down, need to be up quickly again. You can also ask your technology quality departments, which of the lines are very expensive because of what is in the process when it goes down. If you have something like a forge or a kiln, that's things that heat up a lot of metal or other material, and that when that system breaks down, sort of the steel in your kiln just starts to settle on the kiln itself. Oh, that is a mess when you have those things. So a stop in one of those heating processes that really does something actively to your product, those are very expensive. While if you have a stop in the assembly area, where basically your product is stable and doesn't really do anything, you only waste time. You don't waste that much of the product. So think about these things. And those are just a few criteria. Also, you want to be thinking about entire lines. Which whole lines in our factory are critical? We're thinking on the machine level. With this, you make your first split. You make your ABC in that way. Then, when you have that, you can sort of start to ignore already the C lines and maybe even the B lines. Right? You know that all of the parts on that machine, they're all going to be C or all going to be B, more or less. So on a B line you can have C parts, but they are not your primary concern for setting up your system yet. You will take them along in the journey, because when you professionalize your maintenance efforts and the whole organization around it, it's not just the department, but it is focused around the maintenance department, they will also get an upgrade in their systems and the reactivity to problems. Those A lines, you with them go a step deeper, and I still don't think you should extend the number of criteria too much. What you do there is you're going to check, so which parts of that line really determine whether it goes down or not. So do we perhaps have spare conveyors anyway, or can we, when this boxing robot breaks down, just quickly put a pallet there, 2 extra people, and have manual packing for a little bit of extra cost? Then this part of the line becomes a B or maybe even a C, although you will not very often see that a big part of a line that is A for the whole factory becomes a sort of a C part, but you get the gist, right? On your A lines, you check which parts will really stop that whole line immediately, and which parts, well, they are a nuisance, but you only do this for your A lines. Don't forget that your utility systems may very well become A because of the lines. So if you run a plant with a lot of heating, you might have a steam generating system. Right? You've got the steam boilers, they supply the lines so that the lines heat up the product using steam. Probably in most factories this will be an A line, right? Although you have to look at your total steam generation. But the thing is, you don't really go into all of those utilities at the start. First you ask the rest of your operational colleagues, production, quality, planning departments, which production lines are super important. And then you, as the maintenance and engineering team, you will know, right, that line really needs steam, it really needs cooling agent, and how did we have this organized? And then you can use your knowledge to go that step deeper. You can say, well, if we have only these A lines, to actually keep these 5 lines up and running, 2 out of our 4 steam boilers are enough. So if one of the boilers is down, we might have to close down some of the B and C lines from time to time, because we need all 4 steam boilers to generate the whole usage of the factory. But it's sort of enough to keep the A lines running. It becomes a B line. The steam generation becomes a B type of machine because of these circumstances, because of these assumptions that we take decisions. This is something that is a lot easier when you first know from your colleagues what is important for production. So start simple. It will also give you enough guidance on where to start your first project. You want to improve the reliability of those A lines. You want to probably set up AM in those A line areas as well. And you can determine which utilities and extras are needed for that. Then you can always make it more complex when your maintenance organization becomes more mature, is more standardized, and can handle all kinds of different inputs. And also when your ratio of preventive to corrective maintenance becomes higher already. And so when you are still running a factory with loads of breakdowns and unplanned maintenance, you don't need a very strong ABC classification. You just need to get the highlights. So start there to make it quicker to get to action on those first improvements. We are talking continuous improvement that also goes for the tools themselves. So we start simple, and we also, when the performance of the factory improves, then we also improve the quality and the depth and the time we spend on the tools that we use to analyze, to determine potential, to manage our systems. So if you like that explanation, don't forget to hit that like button and let me know in the comments, how interested are you in TPM subjects? I sort of noticed that when I make a very TPM-centered video, not a lot of likes. How alive is this philosophy of continuous improvement still for you? Let me know in the comments. And would you be interested in content on it? Well, maybe you just already know everything because there's years of books on TPM. But maybe you have also specific questions on it. Don't hesitate to put those in the comments below. For now, I wish you the best of luck with your plant maintenance, all kinds of priority analysis, and as always, don't forget to also enjoy the continuous improvement journey.